Today, we're going to be talking about learning, and learning is sort of the opposite side of the nature-nurture debate in the sense that there are some aspects of behavior that don't need to be learned. They're simply reflexive. We're born with them, and there's nothing that is required on the part of an organism in order to develop a behavior in terms of their experience, but rather, as I said, it's innate. It is present more or less from the time that we're born, and usually genetically determined. So learning, on the other hand, represents changes in our behavior that are a result of experience. And so that's sort of the definition of learning. It's typically defined in psychology as a relatively permanent change in behavior or mental processes caused by experience. And traditionally, psychologists have used the terms learning and conditioning as relatively synonymous, relatively interchangeably. Conditioning is the process of learning associations, really, between stimuli and behavioral responses. Or sometimes it's just learning associations between stimuli, but usually we're interested in the behavioral response that indicates that these associations have been learned or conditioned. Now, let me just also mention at the beginning that what is learned can also be unlearned. But when I say unlearned, I don't necessarily mean forgotten, although certainly that is a possibility. But rather, we're capable of making new associations that can break the old associations that have been developed. Okay, so that's what we're going to be talking about in this lecture. And we're going to start out by talking about really the first type of conditioning that was studied and became sort of the realm of investigation for psychologists. Although interestingly enough, it was discovered by an individual who is not a psychologist. And because this is one of the first types of conditioning that was really studied, it's called classical conditioning. So sometimes it's called Pavlovian conditioning because it was developed or first discovered by a man named Ivan Pavlov. He was actually a Russian physiologist, not a psychologist, but he became very well known for his research on conditioning, specifically this form of conditioning called classical conditioning. Okay, now you'll see that it's an involuntary form of conditioning, which essentially means that it can occur without any conscious regulation. It can occur without us being aware of the fact that it is learning. Okay. Now there are actually a number of key terms that you're going to need to become familiar with. So it's going to be really important if you really want to understand classical conditioning that you get a good sense of what these different terms are. Okay, so first of all, classical conditioning, just to provide you with a definition and a framework with which to think about this, is learning through involuntarily paired associations. Okay, it occurs when a neutral stimulus is paired with an unconditioned stimulus to elicit a conditioned response. So as I said, there's a lot of terminology in here. It can be very confusing. So we really need to talk about what these different stimuli and responses are and what unconditioned, conditioned, and neutral refers to. Okay, so just to help you sort of remember this, unconditioned, remember conditioned is sort of synonymous with learning. So when you think unconditioned, think unlearned. It's something that did not have to be learned. So an unconditioned stimulus is a stimulus that you didn't have to learn about in order for it to evoke a response from you. In other words, if somebody pinched you, you'd have a natural response, an unlearned response to pull away. So the pinching would be the unconditioned stimulus because you didn't have to learn anything about a pinch being an aversive stimulus, one that you want to get away from. And because your response is just naturally to pull away from it, to get away, that's called an unconditioned response, once again, because it did not have to be learned. So, if you want to think about the technical definition, again, an unconditioned stimulus is an unlearned stimulus that naturally and automatically elicits an unconditioned response. And again, that's without previous conditioning because of the fact that it's unlearned. It's unconditioned. An unconditioned response is simply an unlearned reaction to an unconditioned stimulus, again, without previous conditioning. If we want to know whether something is an unconditioned stimulus, the true way to make that determination would be to answer the question, the first time that an organism ever encountered that stimulus, did it elicit a particular response? If the answer is yes, then it's an unconditioned response and an unconditioned stimulus, therefore. If, on the other hand, the first time that an organism encounters a stimulus, it does not elicit any particular response from the organism, then it would be a neutral stimulus. Okay, so a neutral stimulus is a stimulus that before conditioning does not naturally bring about the response of interest. So again, we've got a lot of terms here. It's important to just look over these definitions, but it's more helpful to go through an example. So a conditioned stimulus is really one that has been previously paired with an unconditioned stimulus, and therefore it becomes capable of eliciting the same response as the unconditioned stimulus. The conditioned response then is the response that occurs on the basis of being exposed to the conditioned stimulus. So again, this is going to be very confusing. I'm sure the first time you've ever encountered it. So let's walk through an example here. This is the classic study that Pavlov did in order to make his discovery of this process called classical conditioning. So in this case, before conditioning, the neutral stimulus, which is one that produces no relevant response, is a tone. That is, if you ring it, make a tone sound, a dog, the first time he ever hears it, will not elicit it, he will not show any particular response. Okay. However, the first time the dog is presented with meat powder, that automatically leads to salivation because it's automatic and it didn't have to be learned. It was the first time ever that it occurred. The first time it was ever presented with that stimulus that occurred. That determines that the meat powder is an unconditioned stimulus, and the salivation response is an unconditioned response. Now, whether a response is unconditioned or conditioned is completely dependent upon whether it was evoked by a conditioned or an unconditioned stimulus. Because as we see, salivation that occurs to meat powder is unconditioned, but salivation that occurs in response to a tone is conditioned. So it's the same response, but whether it's conditioned or unconditioned is determined simply by what elicited it. So during condition, the neutral stimulus is paired repeatedly with the unconditioned stimulus in order to produce the unconditioned response, but after conditioning, the neutral stimulus has become a conditioned stimulus. So it now produces the conditioned or learned response, which is usually, again, very similar to the previously unconditioned response, except usually it's a little bit less intense, the response. So there would be less salivation, in other words, from the sound of a tone than there would be from meat powder. Okay? So hopefully that example will help you keep these terms straight. And there's also a good example of a modern day example there that you can apply to yourself as well. Now, there was a very famous psychologist named John Watson who did a very classic study now. This is now known as the Little Albert study. Okay, little Albert is that little baby, that little infant in the picture there. What happened was previously a white rat was not aversive to little Albert. He didn't seem to mind it at all. It was a neutral stimulus. However, every time little Albert went to touch the rat, John Watson and Emily Rayner on the side there, they would make a loud noise behind little Albert's head to scare him. Okay, the loud noise is an unconditioned stimulus. We don't have to learn that loud noises are aversive. And so by pairing these two together repeatedly, what they essentially demonstrated was that fears can be learned. Okay, this may sound somewhat obvious, but at the time this was a very novel finding. It was the first scientifically controlled study that demonstrated the mechanism by which fears can be acquired, and therefore has implications about the way that phobias develop. Phobias are actually psychological disorders. But this applies, this classical conditioning, which in this case, because it's an emotional response, would be termed a conditioned emotional response. It applies to things like likes, dislikes, prejudices, phobias, and even love. Now, there are 6 principles of classical conditioning that you should also become familiar with. And we're going to walk through these one at a time and take a look at each one, but this is a nice summary table here. The 6 principles are acquisition, stimulus generalization, stimulus discrimination, extinction, spontaneous recovery, and higher order conditioning. So we're going to walk through these together. So the first principle, acquisition. This has to do with the process through which the pairing of the CS and the US leads to an increase in the response. Okay, this is sort of the pairing of these two stimuli together so that the CS comes to acquire the same properties of the US. And as you can see here, as you increase the number of trials, you also increase the response rate. So, you know, in the classic Pavlovian example, the more times the bell and the meat powder were paired together, the more salivation the bell was capable of eliciting from the dog. Okay. Stimulus generalization refers to the fact that similar stimuli to the original conditioned stimulus elicits the same conditioned response. So initially, Pavlov looked at low-pitched tones and found that those could be conditioned, but then he also found that if you play a high-pitched tone, which is a different stimulus, they sound very different than one another, that the high-pitched stimulus was also capable of eliciting that conditioned response. Okay, so that's what stimulus generalization is. Okay, another example might be you get stung by a bee and you learn that you become fearful of all insects that have yellow and black stripes, regardless of whether they're actually capable of stinging you. That's stimulus generalization. Stimulus discrimination, on the other hand, is when only the conditioned stimulus elicits the conditioned response. So I mentioned that if we get stung by a bee, we typically become averse to all insects that have yellow and black stripes, but as I said, not all of them are capable of stinging you. So if you become an expert in insects and you can discriminate those insects that look like bees but are really not, they're not capable of stinging you, you would learn that you wouldn't have to be fearful of the ones that are incapable. You would become capable of distinguishing or discriminating between the two stimuli, such that the non-stinging insect would no longer be feared. Okay, extinction refers to the gradual disappearance of a CR when an unconditioned stimulus is withheld whenever the CS is presented. So in this case, if you just kept on ringing that bell, which was the conditioned stimulus, over time, and the dog was never presented with any food afterward, eventually what you see here, as time increases, the response rate would actually decrease. So that point at which the conditioned stimulus no longer is capable of eliciting that response, that is, you ring the bell, and at some point you'll get less and less salivation from the dog to the point where he just doesn't salivate at all. That's the process of extinction. Interestingly enough, however, going back to the idea that this extinction process, at first it was believed that the dog had simply forgotten that the bell was a conditioned stimulus, or that it was associated with the food. But that doesn't appear to be the case. How do we know? Because of a phenomenon called spontaneous recovery. This is the sudden, temporary reappearance of a previously extinguished conditioned response. So what happens is you extinguish the response such that the dog is no longer salivating to the sound of the bell. The next day, however, you present the dog with the bell, and all of a sudden you get spontaneous recovery. That is, you get the dog to start salivating again, even though at the end of the previous day he was no longer salivating to the sound of it. So that's what spontaneous recovery is. And finally, higher order conditioning is a little bit complex, but it basically involves the conditioning of a neutral stimulus not by presenting it with an unconditioned stimulus, but rather by presenting it repeatedly with a previously conditioned stimulus. So in this case here, we've got a tone that gets paired with the meat powder, and through conditioning, this conditioning process, the tone becomes a conditioned stimulus. But now, if we want to pair a flashing light, if we want to condition a flashing light, which again was previously neutral, we pair that with the sound of the tone repeatedly, and that will condition the flashing light to produce the salivation response as well, because it's been paired with a previously conditioned stimulus. So really the only difference here between higher order conditioning and just regular classical conditioning is that you never actually pair the neutral stimulus, in this case the flashing light, with the unconditioned stimulus. It never gets paired with the meat powder directly. It's only paired with the a previously conditioned stimulus. So this actually can be seen in everyday life. With the example being prejudice. If a conditioned stimulus, previously neutral, a member of a disliked group, a child sees a parent's negative reaction, over time, the child will start to develop, this association between a parent's negative reaction and the member of a disliked group, and the child can become upset and fearful around them, and that's one of the ways that prejudice can develop. Another example. Classical conditioning, can explain, as I said before, why we develop phobias. Okay, the first time that you see a cockroach ever in your life, you're probably not going to be afraid of it, unless, of course, there's stimulus generalization. That is, you've seen other insects that you didn't like, and so the cockroach just becomes generalized to. But in some cultures, it would be strange to be fearful of cockroaches. So the way that we can explain this is through seeing other individuals' reaction to them. So an unpleasant reaction getting paired with the cockroach, that's what ultimately leads to that aversion. Once again, another practical application of classical conditioning can be seen in some attempts to treat alcoholism. Okay. In this case, there is actually a drug that is capable of blocking the breakdown of alcohol. It blocks one of the enzymes that breaks down alcohol. And what happens is when you ingest alcohol, because your body is not breaking it down, it can become toxic very, very quickly, and a person would become nauseous. So what happens is the nausea becomes paired with the alcohol, and that makes alcohol become more aversive to the point where you don't want to ingest it anymore. So that's an example of a practical application of classical conditioning. The other major type, there's a couple other types that we're going to talk about, but the other major type of conditioning is called operant conditioning. Okay? And this is a more considered to be a more voluntary form of conditioning. In operant conditioning, this is learning through voluntary responses and its consequences. That is, the consequences of our behavior are what shape the future likelihood of us either engaging in that behavior again or not. And so reinforcement is really just a process that strengthens a response. It makes it more likely to occur. Punishment, on the other hand, is a consequence that weakens a response and makes it less likely to occur. Okay, these two things cannot be overemphasized. Once again, it's very important to remember that reinforcement always involves the increase in the strength of a response. It makes behaviors more likely to occur. And punishment always makes behaviors weaker and or less likely to occur. Okay, so remember that. We're going to come back to it in a minute because there are different types of reinforcement and punishment. Okay, this was initially the foundation of operant conditioning. Can actually be seen in the work of a psychologist named Edward Thorndike, who did some work looking at cats and how they would behave in order to acquire a desired effect. And because he was looking at the behavior as a function of the effect that the organism was intending to produce, it became known as the law of effect. Okay, so this was Thorndike's rule that the probability of an action being repeated is strengthened when it's followed by pleasant or satisfying consequences. But the person that is really associated with the development of operant conditioning is B.F. Skinner. Okay, he emphasized that reinforcement, which again increases the likelihood of a response, and punishment, which decreases it, are really what governs the majority of our behavior. And these two things are always defined after the fact. So remember, it's all about the consequences. You cannot know whether something is a reinforcer or a punisher for an individual. For example, some people like chocolate ice cream, and so if you give somebody chocolate ice cream for doing some behavior, that might act as a reinforcer. On the other hand, some people do not like chocolate ice cream, and so if you give them chocolate ice cream for engaging in a behavior, that behavior may not become any more likely because the person doesn't find ice cream to be appetitive. So that's what I mean when I say it's all about the consequences. Okay, we cannot say that a particular behavior or stimulus is either a reinforcer. It always depends on what effect it has on behavior. Okay, for example, even within the same individual, whether something acts as a reinforcer over time can vary. For instance, if you are eating chocolate ice cream and you love chocolate ice cream, there's going to become a point where you've had so much ice cream that ice cream is no longer reinforcing. Okay, perhaps this can be best illustrated at Thanksgiving time when people tend to ingest large amounts of food. At first, Thanksgiving meals are usually very delicious and very reinforcing, which is why we continue to keep on eating them. But over time, the food loses its reinforcing value. Okay, so that's what I mean when I say that it's all about the consequences. Food at one point in time may be reinforcing. At another time, it could actually be the opposite. It could be punishing. You know, you eat so much that you start to get a stomach ache. Okay, so this is Thorndike's box here. What he found was that when you put a cat in a box like this and it doesn't know how to get out, it accidentally ends up tripping the mechanism that opens the door, lets the cat out, and it gets access to a food reward that's located just outside the box. If you put the cat back in the box, what you see is that even though it most likely didn't know exactly what it did to get out of the box the first time, it takes less and less time for the cat to get out each time. Because he may not know exactly what he did, but he may know that he was in, say, the right rear corner of the box when he got out, and so he tends to spend more time there. And then, over time he learns that, he was jumping around while he was over there, and again, that behavior becomes reinforced in a way because eventually he trips the lever that opens the door, and that's how he sort of figures that out. That's what really resulted in the development of this law of effect. Okay, now I mentioned that there are actually different types of reinforcers, but again, you must keep in mind that reinforcement always strengthens a behavior. Okay. Now I say that because there are both positive and negative reinforcers, and it's very common for people to confuse negative reinforcement with punishment, but they're actually the opposite. Okay, because remember, reinforcement is always a process by which you increase a behavior or strengthen a behavior. Okay, the positive and negative, which precedes reinforcement, simply has to do with whether you take something away, negative reinforcement, or add something. Okay, so when you think of positive and negative, you should think of addition and subtraction. Giving something is positive, taking something away is negative. For example, giving somebody giving a child a toy for cleaning their room, if that results in them being more likely to clean their room or strengthens the cleaning of the room behavior, that's an example of a primary reinforcer. But if you were to pick up a crying child because you're trying to get the child to stop crying, then the picking up of the child is a negative reinforcer. That is the cessation of crying, which is something that we want to try to avoid, we want to try to stop, get away from. Taking that away is what increases the picking up of the child behavior. Okay, so that's positive reinforcement involves providing the organism with something that's usually desirable, and negative reinforcement refers to removing something that is usually undesirable. So, for example, just taking a pain medication to remove pain is an example of negative reinforcement. Again, because you're removing something, pain, that is found to be aversive. The other distinction to make about reinforcers is that some are considered primary, others are considered secondary. Primary reinforcers are those that are capable of reinforcing an organism simply because they satisfy some intrinsic unlearned biological needs. So classic examples of this are food, water, sex, even just contact. Social contact and whatnot. Secondary reinforcers are stimuli that are only reinforcing because they've been learned to be reinforcing. So good test of this is to provide an infant with something that you believe to be a secondary reinforcer, and if it's not reinforcing to them, then you know that it's a secondary. You know that it's not a primary reinforcer. What I mean by this is that my daughter, who's only 5 weeks old, she would have no interest in money, but most of my students, I presume, would have a strong interest in money. That is, if I just presented some money to my daughter, she wouldn't be interested in it. It would not be reinforcing. Okay, money is only reinforcing because of the fact that it's become associated with other reinforcers. It was learned to be reinforcing, in other words. Now, the other, when it comes to reinforcement, there are different schedules of reinforcement, and the schedules of reinforcement really just refers to the rate or interval at which the reinforcers are provided. So in the case of continuous reinforcement, every response is reinforced. For example, most vending machines, you put money in, you should always get a soda out of the vending machine or a candy bar out of the vending machine. That's continuous reinforcement. On the other hand, partial reinforcement is when some but not all responses are reinforced. So an example of this would be a slot machine. Sometimes you put money in and get money back. Sometimes you put money in and you get nothing. Okay, but there are actually a number of different schedules of reinforcement, but the two or the four most important schedules to be aware of are fixed interval, fixed ratio, variable interval, and variable ratio. So fixed just means that it always occurs at the same time. Not at the same time necessarily, but it's known when reinforcement will be provided. Okay, that's what fixed refers to. Okay, fixed meaning it doesn't change. Variable, on the other hand, means that it does change. So therefore, you don't know when reinforcement will be provided. So I just talked about a slot machine as an example. That slot machines work on a variable ratio schedule because you could have to put money in the slot machine 10 times before you get money back. That is, before you get reinforcement, or you could get it back the first time you put money in. Okay, so it's on a variable ratio schedule because you never know when it's going to occur. Ratio in this case means that it's based on the number of responses. Okay, interval, on the other hand, means that it's dependent upon the amount of time that elapses. So in fixed ratio schedules, reinforcement occurs after a predetermined number of responses. It doesn't change. Variable ratio is a schedule in which reinforcement occurs after a varying number of responses. That is, you don't know when reinforcement will be provided, but it is based on a certain number of responses, but that always changes. Fixed interval refers to when reinforcement occurs after a fixed period of time, so always after 20 seconds, waiting 20 seconds, that's when you can engage in the behavior in order to get reinforcement. Variable interval refers to when reinforcement occurs after varying periods of time. So once again, you don't know when it's going to occur. In terms of the use of partial reinforcement, one way that we can get organisms to engage in complex behaviors, for example, seeing this primate here on a surfboard, is a very complex behavior. Okay, most of the things that you'll see the animals do at SeaWorld, for instance, seals balancing balls on their nose, that's a complicated process, and you're not going to just get them to do what it is that you want them to do right away, and that's where shaping comes in. Shaping refers to reinforcement of a series of successively improved steps that lead to the desired response. So you start out with a very basic thing. So first of all, in order to get a seal to balance a ball on its nose, you'd have to get the seal to go near the ball, first of all. Okay. Then you'd have to get it so you'd reinforce that behavior first, but then eventually you'd stop reinforcing that behavior, and you would reinforce it only when it lifted up the ball, for instance. It didn't have to balance it on the nose yet, but just lifted it up. Okay, so you start reinforcing that behavior, and then once it's capable of lifting it up, then you only reinforce it when it can keep it on its nose for a certain amount of time, and then you can reinforce differing amounts of time depending on how long you want the seal to balance it for. Okay, so that's shaping. Okay, punishment. Remember, punishment decreases the likelihood of a response. And just like with reinforcement, there are different types of punishment. There's positive punishment and negative punishment. Remember, positive in this context always refers to the addition of a stimulus. Negative always means the removal of a stimulus. But punishment, regardless of whether it's positive or negative, always results in the weakening of a behavior. How do we know if something is a punisher or not? Remember, the only way we can answer that question is to look at the consequence. Okay? If providing a stimulus following a behavior results in a decrease in the strength of that behavior, that's when we can say that that we've identified punishment. So as an example, having to run extra laps, which for showing up late to gym class, if it decreases the likelihood that you will be late next time, would be an example of positive punishment, because you've applied something, you've added something, the extra laps, in order to decrease the behavior. On the other hand, being excluded from gym class because you were late, if that decreases the probability that you'll be late next time, would be an example of negative punishment, because you've just removed something. You've removed the individual from participating in gym class. As another example of operant conditioning in sort of everyday life, prejudice can actually be viewed as reinforcing, or for that matter, bullying and other sorts of problematic behaviors can be reinforced, because you can gain attention and approval from others. Attention and approval from others, those would be good examples of secondary reinforcers. They can increase one's self-esteem at the expense of the victim. People can generalize from one negative experience with a specific group member to all members of the group, just like as I talked about with the stinging insect example. And even racist behavior can be reinforced on an intermittent schedule. And intermittent schedule, meaning that it's not reinforced every time, these are these are highly resistant to extinction, and that's exactly why people continue to play slot machines, because they're being intermittently reinforced. Okay, to illustrate the difference, you wouldn't continue putting money into a vending machine if you didn't get reinforced every time, right? You're not gonna, if you put money in and you don't get a can of soda back, you're not gonna put more money in there. But you would do the same thing in a slot machine. Why? Because the difference is that you're used to continuous reinforcement with vending machines, but you're used to partial reinforcement or intermittent reinforcement in the case of slot machines. Now, just generally speaking, punishment is typically considered to be less desirable in terms of changing behavior than is reinforcement, for a number of reasons. One, there are a number of side effects of punishment. It can result in passive aggressiveness, avoidance behavior, inappropriate modeling. That is, sometimes you model an undesirable behavior by using punishment. It temporarily suppresses behavior rather than eliminates it. It can result in a phenomenon known as learned helplessness, which is when after repeated attempts to achieve some goal and you failed, you essentially give up trying. And it can also reward and perpetuate aggression as well. So reinforcement is much more desirable than punishment, just generally speaking. So when we compare classical and operant conditioning, remember, classical conditioning is when two stimuli, a conditioned and an unconditioned, are paired together to elicit conditioned responses. Okay, so really it's the association or the development of an association between two stimuli. Okay, in operant conditioning, on the other hand, it's the association, the development of an association between a behavior and its consequence. And remember that those consequences can either be reinforcement or punishment. So as I said, generally speaking, we want to try to reduce the use of punishment as much as possible, but anytime you're attempting to utilize these principles, you want to be sure to provide clear directions and feedback about what is being reinforced or punished and why. Use appropriate timing. That is, the sooner that punishment or reinforcement is implemented after the behavior, the more likely it is to be effective. And being consistent. That is, if you're only punishing, the behavior every 1 out of 3 times that it occurs, that's not going to be effective. But if it's punished every time, it will be more effective. Okay, the other major type of learning is social cognitive learning, which emphasizes the roles of thinking, that's the cognitive component, and social aspects of learning. Okay, so cognitive learning really refers to the fact that learning can take place, in our minds without any observable behavior going on at the time that learning has occurred. Okay, a good example of this is called insight learning. This is when there's a sudden understanding of a problem that implies the solution. So most of us have experience with this type of learning called insight learning, where we're trying to figure out the solution to a problem and it's just not coming to us. We don't seem to be making any progress, and then all of a sudden we realize what the solution is. It just comes to us. We don't know how it comes to us, but it does. And that's what insight learning is. Latent learning, on the other hand, is a hidden type of learning that exists without any behavioral signs. So what I mean by this is that typically the way that we assess whether learning has occurred is by looking at overt, which means observable behaviors, but we can see that learning can be occurring without any observable changes in behavior. That is, sometimes a behavior is not demonstrated that indicates that learning has occurred, yet it has occurred. Okay, this was really demonstrated in the early or mid 20th century by a psychologist named Edward Tolman, who showed that rats who were running around in a maze but not being reinforced were still capable of learning the route to get out of the maze. And Tolman suggested that what happened was these rats are actually developing what are called cognitive maps. These are mental images of the space that the rats were navigating in. Observational learning, this gets at the social component, or the social aspect of learning, is when learning new behaviors or information occurs by watching and imitating others. Okay, this is also known as social learning or modeling. Observational learning, they all reference the same thing, and these pictures here represent a very classic study in psychology. Conducted by a psychologist named Albert Bandura. What happened was he had children watch an adult in a room with a bunch of toys. And there were two groups of children. One group of children saw the adults behaving aggressively. As you can see here, the adult on the left is hitting the Bobo doll, being aggressive toward it. The other group of children saw that same adult, but she was playing nicely with the Bobo doll, wasn't smashing it in the face with a hammer. Now, the children who saw the adult behave aggressively, both groups of children were then given an opportunity to go into the room and play. And Bandura observed what type of play did the children engage in. And as you can probably guess from the picture on the right there, the children who saw the adult behaving aggressively engaged in the same behaviors, the same aggressive behaviors as the adults that they saw. On the other hand, the children that did not observe the adult behaving aggressively in the room did not engage in any aggressive behaviors. So that strongly suggested that, at least in this case, aggression is partially based upon modeling or social learning. And of course, this had a number of implications for the types of movies that we see and the types of video games that we play, because the question then becomes, well, does playing violent video games or watching violent movies, does that result in similar behaviors in individuals? That is, does observational learning take place in those contexts as well? There have been four key factors that are critical in order for observational learning to occur. The first, of course, is that one has to pay attention. You have to observe what the model is doing by watching them. Then you have to retain that information, of course. Then you want to reproduce it, which sometimes can be done through direct instruction with a model. And then finally, reinforcement will cause that behavior to become strengthened, and over time it increases the likelihood that it will be displayed even in the absence of the model. Okay, now we're going to spend just a couple minutes talking about some of the biological mechanisms of learning. Basically, learning in terms of our brains, it occurs as we've talked about in the previous chapter about the hippocampus. We know that that's a critical brain structure. There are some other brain structures that are critically involved in learning, but that's sort of one of the most well-known ones, that the hippocampus is very critical in terms of learning new information. And at a neural level, what's going on in the brain is that essentially we're developing new connections. That's really what it boils down to. We're developing new connections between neurons that previously potentially had not been connected. There are a number of other things that are going on in our brains as well. A lot of this research has been done in rats, and if you raise a rat in an enriched environment as opposed to an impoverished one. So an impoverished environment would be just a plain old cage with nothing in it. An enriched environment, you can see on the bottom left there, with lots of things to do inside the cage. It results in thicker cortex in the rats, increased nerve growth factor. As the name would imply, this is a chemical that is implicated in the growth of new neurons, more developed synapses, more dendritic branching, and you'll recall that dendrites are the branch-like structures on a neuron that are responsible for helping us to develop these connections between new neurons. And of course, being in an enriched environment also results in improved test performance as well. Another thing that has been implicated in terms of observational learning is, in terms of the neural basis of this, is that there have been a specific type of neuron that's been identified really in monkeys, but there's certainly some strong evidence to suggest that it exists in humans as well. These neurons are called mirror neurons, and these are certain types of neurons that become active both when you engage in a behavior. So if you smile, for instance, these neurons become active. If you see someone smile, these neurons also become active. So that's why they're called mirror neurons, is because they become active both when you engage in a behavior as well as when you observe another individual engage in that behavior. And these are believed to be at least partially responsible for things like human empathy and imitation. They've been found in several areas of our brain. They help us to potentially identify what others are feeling and imitate their actions, hence the empathy and imitation. Although there's still some controversy surrounding, exactly what role these mirror neurons are playing in our brains. There are also some evolutionary factors that need to be considered in terms of learning. We don't come into this world as blank slates. We come into the world with a set of genes that have allowed us to develop and display certain behaviors over the course of hundreds of thousands of years. And biological preparedness, it's refers to this built-in readiness to form certain associations between stimuli and responses. And a good example of this is called the learned taste aversion. Okay, so as I mentioned, typically, in order for classical conditioning to occur, we need to have the neutral stimulus and the unconditioned stimulus paired multiple times. However, in the case of a learned taste aversion, it only takes one pairing for learning to occur, and that learning is very strong. Most people have probably experienced some form of learned taste aversion. It just refers to the fact that if you eat something and then you become nauseous afterward, there's a strong tendency for you to never eat that food again, particularly if that was your first time trying the food. If it's not your first time trying the food, you may not develop that learned taste aversion. But the first time you ever, it could be either a food or a drink, taste something and then you become nauseous afterward, no matter what you do in between eating and becoming nauseous, even if it's several hours, that elapses in between, you still tend to attribute that nausea to the food that you would eat. And so that's a learned taste aversion. It's a very strong form of learning. And finally, there are also certain biological constraints on learning. That is, as I mentioned, we have this this evolutionary history of engaging in certain behaviors. And so because we have this evolutionary history rooted in our genetics, sometimes when we're trying to teach other behaviors that are contradictory to the biological predispositions that we have, we sometimes see a phenomenon known as instinctive drift. This is when conditioned responses shift back toward innate responses. And there used to be a show on television. It's called When Animals Attack. This is a good, if you want to see a good example of instinctive drift, you can watch that television show, because what's typically shown on those shows is that an animal that has been trained and usually domesticated by humans, they show an instinctive drift where all of a sudden they attack, and in part they're usually animals that were biologically predispositioned to have this attack instinct. Humans had attempted to condition them to do otherwise so that they don't attack, but as the name of the television show, as animals attack would imply, sometimes their biological constraints can overcome this conditioning.